Okay, let's try another hypothesis test with p equals 40.43. So assuming it's 43% likely that you'll make the shot. Okay, but since we actually made 34 shots, we're going to do a one-sided test to see how likely it is to make 34 shots or less. So another way of saying that is, so alternate hypothesis is P is less than 0.43. Okay, and we want to test, so the probability of making 34 baskets or less. So K less than or equal to 34. Let's K, let K be the number of baskets made. Okay, so let's do so to do this we need to find, maybe we could find the probability that K equals 34. So put this in Google again, 100 factorial. So remember it was binomial, so it was 100 choose 34 times 0.43 to the power of 34. 1 minus that is 1.57 to the power of 66. So just put it in Google. And you get a pretty big number, so this is why it's going to be a little bit harder than before. It's small, but it's not small enough. You can just simply times it by like 34 to bound the smaller probabilities. So the probability of K equals 33 will be less than this. It'll be a lot more less than this, but if this was small in the first place, you could just use the fact it was less than it and times, and just use this to approximate all the other ones. But this is not small enough. It's like the 1.5%. Okay, so maybe we can do some more until we get to something that is small enough that we can just not worry about the rest. So maybe P of K equals 33. Yeah, I'm gonna stop doing this once after this one, like writing out the formula. This should be 67, 33. So this should be 0, 0.57. If you want to type this calculation onto Google or something, you look something like this. Okay, I'm typing a new one here. Okay, this one goes down to like 1%. So I guess if we do this another two or three times, let's see. So I'm not going to write this formula out again. Something like this. Small. Maybe not quite small enough just yet. $31. Mm-hmm. 69. Look at that. Okay. It's going down not that fast. So far these things add up to about so 1.5%, 2.5%, maybe 2.6%, and then about 3.6%. So there's not actually much room to work with. 3.6%. So if you add another one, it might go up to 4%. It's actually not going down that fast. .02. Yeah, should I keep going? I think this is at 3.8%. Somehow the rest has to be less than 1.2. If it keeps going down at this rate, there might be a chance. Okay, let's do one more. Maybe not small enough. So this is pretty small, but not small enough yet. So if you times this by 10, it would still all be under 5%, but there would not be enough room for the other 20 points. But if you go down one more, so let's see, 28. No, we can go down by 5 more actually. Let's do 5 more. So let's go to 20. I'll go down 4 more. We'll go to 25. 25. 75. So you get something like this. So P of 25. 0.0000. It's 4 zeros and an 8. So that's good because if you times this by like 10, it won't even be close to 1%. So if you times it by 100, it's still less than 1%. Okay. So you can certainly times it by 25 and it's still less than 1%. And if you times this by 4, it's about 0.5%. Add this together, it's 1%. We had 3 and something percent. So actually now we've shown that if you add them all together, it'll be less than 5%. Because we got, 1.5%, 2.5%, 3 point something percent, maybe still less than 4%. Times this by 4. Times this by 25. I think when you add them all together, it'll be less than 5%. So this probability here is less than 5%. And so this is considered out. Making 34 out of 100 is significant evidence against the hypothesis that your true shooting percentage, or not true shooting percentage, just shooting percentage, like your theoretical shooting percentage, is 43%.